Hi guys, welcome back. I hope you are a bit refreshed now and you can still go on with me until the end of our session. Right now we are still looking at some similarity calculations, specifically some riders, right? So the next question will have to do with proportionality theorem when I have one side parallel to the third side of the triangle, which will then cut the other two sides in proportion, right? But let's just see how to solve these questions. Now here they say triangle PQR has S on PQ and T on PR, such that what is important, ST is parallel to QR. You can see with the arrows there, right? And then they tell us now that PT is 4 units. This is 4 units. That's the length. SQ is 9 units. That's the length we are given. TR is 6 units there. And now 2x minus 10 will then be the PS, right? Then they want us to calculate the value of PS. So with this, there isn't really information that I need to then add on the diagram because it is already there. The only thing I need to know is what does the parallelness of these lines do for me on this diagram. So let me then show you. Right? So, because the lines are parallel, it means that this side over that side must be equal to the PT side over the TR side. Why? Because of the proportionality theorem. So that's our leading point there. So I'm definitely going to then say PS over SQ must be equals to PT over TR. And what is my reason for this? It's because line parallel to the other side, right? Side of a triangle. Or you can simply just say prop theorem, proportionality theorem. You can just easily just say that and that is fine. And then let's substitute and then solve for PS, right? So what do I know? I know PS was given to me as 2x minus 10 over my SQ was 9 equal to my PT was 4 over my TR was 6. Then you simplify this. I will then have the 6 multiplied by the 2x there, which will give me 12x. The 6 multiplied by the 60 will be minus, by the 10 I mean, sorry, it will give us minus 60. I'm already thinking about the answer there. And then the 9 multiplied by the 4 there will give me 36. And then I can then work out this, right? So this will be 12x is equals to, if I add the 60 on both sides, it will give me 96, right? And then I find what my x is quickly. So let's quickly just press the calculator so that we get the correct answers. Divide this by 12 and that will give me 8. So x will therefore be 8 units. But is this what PS is? No. This is just the x value of that PS that we are dealing with. So quickly, my PS will, so you say therefore PS is equals to 2 multiplied by 8 minus 10, which is 16 minus 10, which is supposed to be 6 units. And then you will therefore be done with that. Now, let's look at something else, right? So I said, whenever there's some information we need to add, I'm not going to give you some questions as we are starting. We have the triangle PQR with B that lies on PR, such that 2PB is equals to BR. So 2PB is equals to BR. So that means BR, if I let maybe BR to be X, therefore that will make the 2PB to be 2X, right? So where is my BR there? So if I make this X there, right? Or 2X rather, and it will then give me X for PB. This will therefore be X like that, right? So I can add that information. And then also, what do I know? I know that I have a ratio of PA and PQ as a 3 is to 8. So PA, which is this, and PQ, which is the whole one, is a 3 is to 8. Please understand something, guys, here. Whenever I give you a ratio, I am not saying that the lengths of that are 8 and 3. No, the ratio. So I'm saying to you, how many times does this length go into that length is in a ratio of 3 is to 2. So for example, if I say the easier ratio, 1 is to 2. If this is 20, right, the one that has 1 as a ratio, this one will therefore be 40, right? So that's what it means. Not that the 1 is to 2 means that this one is 1 unit and that is 2 units. Please understand that. Ratio and units are not the same thing. Ratio is just how do they compare to one another in terms of whatever their lengths are, not what the lengths are. Now, let's see what the questions will then be. So, write down the value of the area of PRA and QRA, right? Now, firstly, we're going to write everything that we know. What do we know? We know that this PA here is in the ratio of 3 is to 8 to my PQ there, right? So this is 8. And then also I know that my BR is 2x when my PB is x, right? And then I want to talk about the ratio of the areas. The main thing that I must look for is are the areas between are the triangles between two parallel lines or not? If they are, it means they have the same height. So which triangles am I dealing with here? Let me just use a different color. It's PRA, right? So PRA will be that one there. And it's also QRA. QRA there, right? So automatically you can see that the parallel lines will roughly be those ones there. So it makes the RA to be my height, or the height to be from R to that A there, right? So this will mean that I will then have, firstly, you write what is the area. Let me just use the correct color there. So you firstly write what is the area, right? Area of any triangle for that matter, it must be given by half base multiplied by height, right? And then I will call this number 1 and call that number 2. For area number 1, right, for triangle number 1, it will be equals to half. What is the base of PRA, right? PRA, which will be that one there, it will be the PA. So I will have this as multiplied by PA multiplied by my height, which I do not know, right? And the area for the triangle number 2 will then be also 1 over 2 multiplied by, what is my height there? My base, my base will be AQ, right? So this will be AQ multiplied by the height that I do not know, right? But what do I know? I do know that this was given to me with parallel lines, right? And they told me that there's a parallel line which was AR there, and there's a parallel line which was that there. So that can allow me to find the other lengths that I do not know on this particular diagram, right? So since these are parallel lines, it makes this to also have the same ratio, which is a 1 is to 2. So this is 1 is to 2. That's why it's 3 at the end of the day. So do you see? That's how you can then link these things. So area 1 over area 2 will be equals to 1 over 2 multiplied by times the height over 1 over 2 times AQ multiplied by my height. I know that my heights are going to be the same because they're from the same vertex to the same baseline, and the half are going to divide. So I must try and find what is PA over AQ. If I can find that, then it will make my life easy, right? So PA already I know it's going to be 3 in terms of ratio over, I must find what is my AQ. So with my AQ, I can then look at the triangle. Let me just show you. Going back to this, such that, yes, so I know that if I use this whole thing and that 8-1 there, I can then make AQ the subject of the formula, right? So it means that my PQ is the same as my 3 plus 8. Do you see? And 3 plus x, I mean 3 plus x, which is equal to 8, because I don't know what is the other one. So 3 plus the x that I don't know, which is supposed to be equal to 8. Therefore, my x will therefore be equal to 5. You see, so making this just 5 units. So this will be 3 over 5, and that will be the value for that. And then we need to write the ratio of BD is to BQ, right? I'm gonna firstly write what I know, that is x, that is 2x. This here is 3, that there is 8, and this there is 5. But remember, all of these numbers I'm adding here are ratios, not necessarily numbers, né? Or the height of this thing, or the length of this. So I want BD. So BD, different color, BD will be that there, and I want it to be the with respect to BQ, which is that one there. So I want this small one with the longer side. So already you can see, guys, that these two are in proportion, right? They are parallel to each other, making that triangle to be in proportion. So I will therefore say in triangle BCQ, right? I know that there's proportionalities that are there, so I will say BC is parallel to AD. Why? I was given this, right? And if that is the case, it means that my CA over CQ is equals to the BD over BQ, right? And then CA value, you know for a fact that it has a ratio of 1 is to 2, which is the same as the one that is that side. So this will be 2 over, then my CQ will then be from C up until Q, which is 2 plus the 5 there, and that will be 7 is equals to BD over BQ. I know this is a lot, guys. Please, I said try to write it down. Just write all of them down, and then after that, try to then link them back to what we've spoken about. All right, so the main thing that you always need to look at here is, as soon as we have parallel lines, right, already you then going to look at maybe A is to B, which must be the same as C is to D. Immediately they are parallel lines. That is what I know about the sides that are in proportion there. And then from there, I can then play around with my sides. So this is mainly proportionality theorem when this is parallel to that. And then this becomes the A, that is the B, that is the C, and that is the D. But it's not only that it makes these smaller sides to be in proportion. Also with the bigger one, see, with the whole side, it also makes it to be in proportion with the other one. As you saw with the previous exercise that we just did here, it makes it to be in proportion with one another. All right, so guys, I hope that is very clear. This is just the proportionality theorem. Area, as soon as those two triangles are between two parallel lines, or the height is from the same vertex to the same baseline, it means that they have the same height. Therefore, the ratio of them will be their bases, right? It will be base 1 over base 2, and then you'll be done. But you must always make sure that you don't confuse the ratio with the length, because those are two different things. But the ratio does tell us how we can find the length, but the length has nothing to do with the ratio. So that's what you just need to do. Guys, let's just take a quick ad break and I'll be back with some more. Please stay tuned.